This is a response to Bill Gaedy's video entitled Number 23, The Slit Experiment, in which he discusses the interference pattern formed by light passing through two small slits. Gaedy's critical of conventional science and claims that wave theory runs into a predicament in that it cannot simulate what happens in the Bill Gaedy needle experiment. By naming it after himself, he implies that he is the first to have this revelation in observing what happens when you put a small obstacle in front of a laser. What he describes, in fact, is a basic Optics 101 lab experiment that's been conducted by students for decades. I reference a few below that discuss using a pin or a wire or a hair to diffract light from a laser. Furthermore, contrary to what Gaedy claims, wave theory can be shown to precisely simulate the situation. Typically, the student will measure the space between the diffraction orders and the distance from the obstacle to the viewing screen to determine the width of the object based on the wavelength of light of the laser. The object can also be directly measured to confirm that wave theory gives the correct answer. Yet here's what Gaedy says.
Waves run into the same predicament. A wave theorist explains that light generates fringes, like water waves do when they interfere with each other after passing the slits.
If the top of one wave meets the bottom of another wave, they cancel each other out. So now, there is an interference pattern on the back wall.
What would happen if we remove the outer walls of the slits? Dr. Quantum provides the answer. Waves that go around the slits do not interfere with each other. They spread out.
Not true. Waves do diffract at the edge of an obstacle, as seen in this simulation. One explanation for Gaedy's confusion may be that rather than using a wave simulation, he shows an animation from Dr. Quantum to try to make the case that waves do not diffract at the edge of a structure. I don't want to be too harsh with Dr. Quantum's video. It's intended to illustrate what happens as a wave passes through two slits. Unfortunately, Dr. Quantum's video is not accurate. In the cartoon, the frequency of the waves double as they pass through the slits. This doesn't happen in reality, and it indicates that the video is not an actual simulation, but simply an animation. Gaedy highlights the regions at the edge of the structure where the waves simply vanish rather than diffract at the edge. When pointing out these errors to Gaedy via the comment section of his video, it became apparent from his responses that he has several misconceptions that severely influence his thinking. He believes, for example, that when a wave moves through a body of water, the molecules of water flow with the wave. He very much wants there to be an object that moves at the speed of the wave. While I'm sure I will never convince Gaedy himself, I hope I can clear up this common misconception for others who share it with him. Here's a wave that propagates through people sitting in a stadium. Everyone agrees to a simple rule. When the person to your right stands up, you stand up, put your hands over your head, then sit down again. It creates an impressive effect. And it's easy to see that in this kind of wave, the particles of the medium, people in this case, do not move in the direction of the wave. They simply move up and down. So if the particles of the medium are not moving, what is moving? Let's do a thought experiment. Suppose everyone had assigned seating and their ticket said something like, at exactly 15 seconds after 3 o'clock, please stand up, put your hands over your head, and then sit down again. Let's make it so each ticket would have a randomly select number of seconds between 0 and 18. At 3 o'clock, we would see the crowd vibrate in a random up and down motion for 18 seconds. No wave. Yet the crowd would be exerting the exact same amount of energy in standing up and sitting down as it took to do the wave. The effort they expend in this case is incoherent. The human wave, on the other hand, is coherent. It can be thought of as a continuous sequence of cause and effect events. When particles move, they exert a force on the particles adjacent to them. In this way, the action of particles is transferred through the material. There's nothing mystical about this. It's a simple chain of events in which each effect is the cause of the next, like dominoes falling over. The falling action starts at one end, and moves down the road. So what happens if we combine the water waves we saw earlier with the human wave? Pick out any person in the crowd and notice that they simply move up and down. They don't move with the wave because the water is not flowing. It's only transmitting the wave action. Bill Gates has some interesting ideas, and people like him should be encouraged to think for themselves and be skeptical of the status quo. But if you don't understand the things you criticize, you end up looking foolish to those who do understand them. Ironically, Gates is so close-minded with respect to any idea other than his own that sadly he will probably never take the time to understand the basics of wave theory. Furthermore, it's annoying to think that people who want to understand waves will be misled by his authoritative tone. But if you want to understand how waves work, you're going to have to talk to someone else other than Bill Gates.